present here. I, myself, Subhrajya ROY, and my teammates, Mr. Anuranchatterjee and Mr. Lincoln Nandy, I am going to represent the topic bioremediation. First of all, I want to thank Sir SOUMYAJIT for letting us do presentation on this topic. Now I call upon Mr. Anuranchatterjee to enhance more on this topic. Thank you.
As to earlier welcome to my friend Subhrajya ROY, this will be said by Subhrajya as well. But to continue on this topic, we would like to present our topic. First, welcome to our presentation. So our topic will be mainly focusing on bioremediation. So it's starting with the quote, let's nurture the nature to have a better future. Please response if I am audible. Audible?
Yes.
Thank you. So as already discussed, there are really three participants, that is Subhrajya ROY, me, Anuranchatterjee and Lincoln Nandy. Focusing on the main table of the content which we will be focusing today. That should be introduction, the three common processes, types, advantage of in situ, disadvantage of in situ, advantage of ex situ, disadvantage of ex situ, types of ex situ, types of in situ, process of bioremediation, application of bioremediation, and various disadvantages of bioremediation, and many more. So to continue on the introduction part of the bioremediation, let's focus. It mainly comes from the word such as bio and remediation. And we all know bio means living and remediate means solving a problem. So bioremediation is a technique of solving a problem using living organisms like microbes. In other words, it's a part of biotechnology that deals with the elimination of environmental contaminants by using microbes, the main biological agents which we consider. So bioremediation is the technique which is most sustainable. Not only that, it do not affect our environment, and it's a very economically friendly nature. So let's nurture the various introduction part of the bioremediation through a video of this.
Bioremediation is the biological process to degrade, break down, transform and remove pollutants from soil, water and air. It relies on bacteria, fungus and plants to degrade contaminants while the organisms carry out their regular life functions. The body processes of these organisms convert complex chemical substances into simpler and non-toxic byproducts. Bioremediation requires very few resources and very less energy than any other treatment processes, and it does not accumulate hazardous secondary pollutants, albeit it takes a bit more time. In today's world, pollution of any kind is a serious problem affecting the environment, wildlife and our whole planet. Bioremediation is a sustainable solution to it, providing us with clean water, clean air and healthy soil for our future generations.
Thank you. Done with the video. So bioremediation is a triple control process mainly involves pollutants, environments and organisms. In part of environment there are soil, water and air. On part of organism there are microorganisms, plants and various enzymes. So basically now coming mainly in the topic, that is type of bioremediation. It is mainly of two, it's mainly classified into two categories, that is in situ and ex situ. In case of in situ, we know it's a strategy where without excavation we can treat the associated groundwater together with soil in its place. In case of ex situ, it's a strategy where the contaminated soil and the groundwater are taken out of original location for treatment. So bioremediation can be further subdivided into various subparts on basis of in situ and ex situ. That's a perlocation, bioventing, biosparging, pump and treat, bioslurring and etc. In case of ex situ bioremediation, there are land farming, compost, piles, irrigation and engineered biocides. So focusing on the various advantage of ex situ bioremediation, we can say we can treat large volume of soil at once. It creates less dust as compared to other processes. It is less contaminant released. and it is the most effective way if permeable sandy soil is present. Now, various disadvantages of ex situ bioremediation are in situ bioremediation, the rate of controlling step is frequently the influx of oxygen. Not only that, the lack of sufficient large microbial population can also limit the cleanup rate. The microbial population may be small because of lack of nutrients, and an inhibitory condition such as low pH and presence of toxic material. Various advantages of the ex situ bioremediation. This is a technique which is faster and easier to control. It is used to treat larger range of contaminants and soil type. There is more certainty about the uniformity of the treatment because of the availability of the homolines, screen mix, soil. Focusing on the disadvantage of the ex situ bioremediation, we can say this is a process which is much costlier than in situ bioremediation. There is more risk of considering material handling to labor. It can be difficult to remove large quantities of contaminated soil or water from the environment. Various subtopics of the ex situ bioremediation can be classified as solid phase and slurry phase. Slurry phase can be further subdivided into composting, biopiles and land farming. Now I request my friend Anuranchatterjee to continue from the 7 parts.
Thank you, Anand. I would like to continue from this slide, composting. Composting is a controlled biological process by which organic contaminants are converted to microorganisms under aerobic and anaerobic conditions to increase and stabilize by product. Secondly, typically thermophilic conditions at temperature 54 to 65 degrees must be maintained to properly compost or soil contaminated with hazardous organic contaminants. There are 3 processes designed used in composting: electrostatic pipe composting, window composting, and vessel composting. Representation of composting figure. In this figure, excavate and spin soil next from windows, soil and ingredients. Next, periodic turning of window and window monitor. Next, compost analysis and window disassembly and dispositions. Biopiles. A biopile is a type of ex situ treatment that uses biological process to transform pollution into low toxic byproduct. Biopile are type of remediation system that is used for a short period of time. It's often used to lower petroleum component concentration in soil by utilizing the bioremediation process to maximize and manage the pace of biodegradation and excavate soil or seed is piled over an impermeable base or pad with erosion. There is figure biopiles. This is clean soil base and contaminated soil. There is condensate collection tank, lower of gas treatment, treated of gas and extracting piping. Land farming. Land farming is the most basic method of bioremediation. Land farming technique is required large area and are not generally for small sites due to the limiting thickness of soil layer, but they can be the cheapest kind of bioremediation. Contaminated soil are blended with the soil ingredients like bulking agent and fertilizer before being tilled into the ground. Land farming is an ex situ waste treatment process that is performed in upper soil zone or in biotreatment cells. View of land farming. There is tilling for soil erosion and contaminated soil and groundwater monitoring wells. There is slurry phase. Slurry phase bioremediation is an engineered process for treating contaminated soil or sludge. Slurry phase biological treatment can be applied to a variety of contaminated waste and to microbial degradation, including manufactured gas plant waste and treating waste refining oils and petroleum hydrocarbons and select chlorine and compounds including ECDs. Commercial slurry phase treatment system was used to bioremediation components at two sites, a wood treatment facility and a manufactured gas plant. View of slurry phase. Reactors, glass tubing, vacuum, rubber stopper, graduated in the fine particular slurry and immediately stable solid. Next, bioreactors. Any manufactured equipment or system that supports a biological active environment is referred to as bioreactor. This process might be aerobic and anaerobic in nature. These bioreactors are typically cylindrical, shaped with size ranging from liters to cubic meters and are frequently composed of stainless steel. View of bioreactors. Bioventing. Bioventing is a form of in situ bioremediation technology that encourages aerobic decomposition. Secondly, by delivering oxygen into an unsaturated zone, it improves the initial capacity of indigenous microorganisms to break down organic pollutant adsorbed to soil. It also reduces pollutant volatilization and into environment. It also reduces pollutant and into the environment. Bioventing system. This is the figure. I would like to request to continue this slide. Subhrajya ROY.
Thank you, Lincoln, for letting us more on this topic. So we now come to the biospurging. So what is biospurging? Biospurging is a process of pumping pressurized air or gas into a polluted area to stimulate in situ aerobic biological activity. This technology targets chemical substances such as mineral oils and benzene, toluene, ethyl benzene, xylene and naphthalene, BTEXN, which is a short form, that can be biodegraded under aerobic condition and is used to treat soluble and residual contaminants in the saturated zone. Now, what is the goal of biospurging? Biospurging, we cannot do like that. We have to have some goals. So, what is the goal of biospurging? The goal of biospurging system is to increase pollutant biodegradation by minimizing the volatile and semi-volatile organic compound volatilization. So, here is the figure of biospurging. Now we come to the next topic, bio-augmentation. Bio-augmentation is a type of in situ bioremediation. As we are, you know that Lincoln already told you that it falls under in situ bioremediation. So bio-augmentation is a type of in situ bioremediation. It involves researching the local indigenous varieties to see if biostimulation is viable. Bio-augmentation is the addition of extra archaea or bacterial cultures to boost the pollutant breakdown, whereas biostimulation is the addition of nutritional supplements to boost bacterial metabolism. A number of synthetic and natural organic chemicals and compounds such as acetone, acrylic acid, ammonia, nitrate, fluoride, phenolic compounds and methylethylamine are examples of industrial waste that contain inhibiting or hazardous substances that can be handled with bioaugmentation products. Now here you can see a figure of bioaugmentation. Process of bioremediation. Bioremediation, as Lincoln already told, is mainly of two types: in situ bioremediation. Don't make me laugh, please. In situ bioremediation and ex situ bioremediation. Now in situ bioremediation falls under two processes, that is intrinsic bioremediation and engineered bioremediation. Engineered bioremediation is biospurging, bioventing, bioscrapping, biostimulation, bioaugmentation and natural attenuation. that is already discussed, and under ex situ bioremediation it falls slurry phase bioremediation, that is bioreactor, and solid phase bioremediation, which is biopiling, land farming, composting, and biofiber. Now we come, what are the application of bioremediation? Bioremediation has many applications, but in brief we told some, like it is used in the removal of contaminants, pollutants, and toxins from soil, water, and other environments, soil and land treatment, drinking and processed water, wastewater, and industrial effluents. Now, what are the factors that affect the bioremediation? Like natural and concentration of contaminants, increased concentration of contaminants affect microbial colony both in growth and in enzymatic function. Natural availability, the presence of essential nutrients for growth and working of microbes such as nitrate and phosphate. pH should be always ranging from 5 to 9 is considered to be the optimum for bioremediation. And temperature between 20 and 40 degrees centigrade is considered to be good. Now, what are the advantages of bioremediation? It takes the advantage of natural ability of microorganisms to extract the chemical from water. It is also very cost effective, often little no residual treatment, and very less energy is required. Disadvantages of bioremediation. There are also disadvantages, as we know that a coin has both sides, so there will be obviously some disadvantages. It does not remove all the quantities of contaminants from the polluted slide. It is very slow in nature and not used for treatment of inorganic components. Conclusion: bioremediation is very successfully used to treat a wide range of contaminants in a broad range of environment contaminants which require bioremediation include crude oil and refined petroleum products, halogenated solvents, pesticides, herbicides, etc. by aiding natural selection and making small adjustments of the local environment to encourage growth of remediating microbes. The process not only lowers the expenses but also is very environmental friendly. Here are the websites that from where we collected the information. And, so thank you for